I'm going to deliver a lecture on open chain structure of glucose. Open chain structure. Glucose, this occurs in free form in honey, ripe grapes. That is why it is called grape sugar. And most of the sweet fruits like mangoes, apples, figs. It is also present in blood. Human blood contains 0.1% of glucose. In combined form, it is component of glycosides, disaccharides and polysaccharides. In laboratory, if we want to prepare glucose, it can be prepared by hydrolysis of sucrose with dilute HCl or sulfuric acid in alcoholic medium when a mixture of glucose and fructose is formed. Glucose is sparingly soluble in alcohol and it separates out while fructose remains in solution. On commercial scale, glucose is produced by hydrolysis of starch with hot dilute mineral acids. When hydrolysis is complete, reaction mixture is neutralized with chalk and filtered. Filtrate is decolorized with animal charcoal and concentrated under reduced pressure when glucose crystallizes out. And the reaction is, this is formula of starch. It is hydrolyzed with hot dilute mineral acids and we get glucose. Common source of starch is rice, maize or potatoes. If we talk of physical properties of D plus glucose, glucose is a white crystalline solid and it has melting point 419 Kelvin. It also occurs as monohydrate whose melting point is 391 Kelvin. Glucose is highly soluble in water but sparingly soluble in alcohol and insoluble in ether. It is about 3/4 as sweet as sucrose, which is table sugar. And if we talk of optical activity, glucose is optically active and is dextrorotatory. That is why its name is dextrose. Now, if we talk of chemical properties of glucose, glucose is a monosaccharide This is a typical monosaccharide. It shows the reactions of aldehydic and alcoholic groups, and it may be conveniently represented for the present as an open chain pentahydroxyaldehyde as shown below. This is open chain structure. This open chain structure of glucose, it has got one terminal aldehyde group, four secondary hydroxyl groups, and one primary hydroxyl group. Glucose, it gives the usual reactions of aldehydes, but it does not form addition compound with sodium bisulfide, and it does not give reaction with the Schiff's reagent. Now, if we talk of the reactions of glucose, first is reaction with hydrogen cyanide. Glucose forms cyanohydrin with hydrogen cyanide. We can write the compact formula of glucose like this. And glucose cyanohydrin is formed. This is glucose cyanohydrin, the first reaction. And it shows that free CHO group is present over here. Next reaction is reaction with the hydroxylamine. Glucose, it forms oxime with hydroxylamine. This is glucose oxime which is formed. Next reaction is with phenylhydrazine. With phenylhydrazine, when glucose reacts in equimolar amount, at room temperature for a long period, glucose yield phenylhydrazone of formula This is phenylhydrazone of glucose. If glucose is warmed with excess of phenylhydrazine, reaction goes further to yield a crystalline product which is known as osazone, which contains two phenylhydrazine residues per molecule. Osazone formation is not only a general reaction of monosaccharides but is also given by all alpha hydroxyaldehydes and all alpha hydroxy ketones. Now, one important point we need to remember here is that osazone formation of glucose, it destroys the chiral character of C2 carbon. Other chiral carbon atoms, they remain unaffected. Next reaction is reduction reaction. Glucose is readily reduced catalytically or sodium amalgam and water to form a hexahydric alcohol which is known as sorbitol or also called glucositol, whose formula is this is formula of sorbitol. On reduction with concentrated HI, hydroiodic acid and red phosphorus at 373 Kelvin, glucose yields normal hexane and 2-iodohexane, which shows that glucose, it has straight chain of 6 carbons. If we talk of oxidation reaction, mild oxidation of glucose with bromine water affords monocarboxylic acid, which is known as gluconic acid. Gluconic acid has got this formula, and if strong oxidizing agent nitric acid is used, then we get dicarboxylic acid, which is known as glucaric acid, whose formula is this is glucaric acid. Next reaction is reducing nature. Due to the ease with which the aldehyde group in glucose is oxidized, it acts as reducing agent and it reduces Fehling solution, Benedict solution and Tollern reagent. With Fehling solution, which is copper ions, sodium ions and hydroxyl ions. Glucose gives sodium salt of gluconic acid plus red precipitate of cuprous oxide and water. Sodium salt of gluconic acid. And glucose reacts with the Tollern reagent to give silver mirror. And that is why glucose is called reducing sugar, because it gives a reaction, positive reaction with Fehling solution and with Tollern reagent. Now if we talk of reaction of hydroxyl group, glucose reacts with acetic anhydride to form pentaacetate derivative, which shows that glucose has got 5 hydroxyl groups. Next reaction is with methyl alcohol where it forms glucosides. Glucose reacts with methyl alcohol in the presence of anhydrous HCl to form methyl glucoside. And with calcium hydroxide, glucose forms soluble glucosides. Other reactions of glucose are fermentation. The enzyme zymase present in yeast readily brings about fermentation of glucose and glucose forms ethyl alcohol. And when heated with concentrated HCl, glucose gives a 5-hydroxy-methyl furfural which is further converted by hot HCl acid into levulinic acid. If we talk of action with alkalis, concentrated alkalis, they turn glucose into brown resins. Dilute alkalis bring about a reversible isomerization and the reaction is called Lowry de Bruyn van Ickenstein rearrangement. Now, structure of glucose, it shows presence of aldehyde group, 5 hydroxyl groups and 1 primary hydroxyl group and 4 secondary hydroxyl groups. And there is straight chain of 6 carbon atoms. So we conclude that open chain structure of D plus glucose. Glucose contains straight chain of 6 carbon atoms. One terminal carbon is in the form of aldehyde group. Other carries primary alcoholic group. Remaining 4 carbon atoms, they carry hydrogen atom and a hydroxyl group to account for the presence of 5 OH groups and 12 hydrogen atoms in all. So open chain structure for glucose. So this is open chain structure of glucose and this structure contains 4 chiral carbons. That means 16 stereoisomers are there. That means 8 pairs of enantiomers are there. So this was all about open chain structure of glucose.